Hello everyone, myself Dr. Sandhya Tapadia. I welcome you for the next lesson in R, which covers data types, factors, and lists. Okay, so what are the data types in general? Data types is an attribute associated with a piece of data that tells computer how to interpret its value. Basic data types in most of the programming languages are integers, real numbers means floating points, characters, and booleans. A data type constrains the value that a function or variable might take. But in R, variables are not described as some data type. Variables are assigned with R objects, and data type of the R objects become data type of the variable. So I can say that everything in R is an object. So frequently used R objects are basically the vector, list, matrices, array, factors, and data frame. Simplest of all is a vector. In fact, we can say that an atomic vector. By atomic, we mean the vector holds the data of single type. Okay. So there are 5 types of atomic vectors which are frequently used in R, namely logical. It has only two values, namely true and false. Integer, which you already know. Then numeric means taking number values. Then complex, it will take complex values. And characters. Okay, for characters, most of the characters, we write them in the double inverted commas. And there is one more data type called raw, which we won't look at today because it's quite rarely used. We are more interested in the above 5 data types. Okay, so let us see how we can declare these vectors in R. So let me go to R Studio. So here you can see my console. Okay, and let's create a atomic vector and let me call it as, say, test data. Okay, so let me call the vector to be as test data because I want to test the data type. Okay, so I'm calling it as test data. You can choose any name to your vector. You can say it to be my vector or whatever name you want. Okay, so the very first type which we saw was logical. So let me write test data. And if I want it to be logical, it can take only the two values, either true or false. So let me try out false. Let me try out true. And says, see, this test data have been created over here. You can see in the environment tab. Okay, and let's check what is the type or what is the classification of this vector. So let me call it as, so the command is class of the test data. And if I press enter, you can see the type to be logical. In fact, here, let me tell you some other variations as well. So here, if I put false, you can see the similar kind of results. I'm just showing you the repeated kind of commands in which you can actually define a logical data type. So even if I put only F or T, it will suffice. Okay. See, in all the 3 cases, you can see that the class of this atomic vector test data came out to be logical. Okay, so this is the way in which we can create a logical vector. There is one more command. Instead of class, we can actually have the command called as print the class of test data, but this is anyways a longer command than the previous one, class of test data. So, but I just wanted to show you both the types, so I have showed you both. So here also it returns me the output as logical. Now let's try to declare another type of vector called as integer. So for declaring it and as an integer, so there are two ways. So I'm keeping the name constant because I just want to show you different types. So I'm not using different names for different vectors. I'm using the same name, but I'm defining it in different ways, and you can see there are different types. Okay. Now suppose if I put here only an integer value, say 12, and if I give the command for the class, you will see that the value returned is numeric and it is not integer, because so far I have not asked it to return me the integer value. To return the integer value, I should put L as suffix. Okay. I should put L as suffix to that integer. Okay. And let me check now what is the class of test data. Now you can see that it is integer. Okay. Now what will happen if I put a numeric, some random number which is in terms of decimal, and then put an L as suffix? You will see there is some error or there is some warning message which comes, because integer, it can identify that it doesn't contain any decimal point. Okay. It's an numeric value. There is one more way to set the value as integer. So there is a command called as.integer. So as.integer returns you integer value of a number. A number could be anything. It can be in terms of decimal as well. I'll show you both the versions. So let me first give only an integer value. And let's check for the output. It returned me the output as integer. And now suppose if I put here 5.3, and let's check what the class it shows. It shows integer because basically as dot integer is the command to return integral value of the number. As you can see, as dot integer of 5.3 is 5. Similarly, as dot integer of say pi, if I put pi, what it would be? It would be 3, because value of pi is 3.141, something like that. So integer part of it is only 3. You can check it for even exponential, you can check it for log, and whatever points you want to enter over there. All right. So either we suffix the integer by L to have that vector to be of integer type, or we use this command as dot integer. For numeric, as I said, you can give any number and it would return you the value numeric. Okay. So let me just show you one more thing. So let me write test data, and suppose if I write here pi, what happens? The class of test data would be numeric because pi is a number. Now there is one more type which is complex, isn't it? So let me write a complex number. See, complex number is of the form a plus ib. Okay. So here, say for example, if I write 1 plus 2i, see what it gives me? It gives me a complex. But unlike our mathematics, if I just only give 1 plus I, it will return an error that object I is not found, because it can't identify only a single I, but it wants to be in the form of I into B. So if I want to have the value of the test data to be 1 plus I need to write 1 plus 1 into I. And now it would return the class of test data as complex. So this is the important thing, as unlike in our usual mathematics sense, we just can't write it as 1 plus I, 1 minus I, or simply I. we need to write the value as 1 plus 1i, 1 minus 1i, or 1 into I, or minus 1 into I, and likewise, and then it can identify it as a complex number. Okay, and the last type, as I said, it's character. For character, we need to write the value in inverted commas. So let me write it as say sat. We can use the special characters also, sat at 1, 2, 3, say for example. And if you check the class, it will return the character. Okay. And in characters, you can have only the name as say SAT, or you can have only a character, special character at, or you can have only the number. But whatever you want to set as character, it should be in double inverted commas. So that you need to remember. There is one more way where we can create an empty vector. Okay, so let me show you how one can create an empty vector. So I will just write vector, and let me write character, and there suppose its length be equal to 3. Okay, and let me put an enter. So it would create an empty vector having 3 characters. In fact, characters are not there because it's an empty vector. So there are no characters as such, but length is 3. In the similar way, you can have it for say integer. And let's see what it returns you for integer, an empty vector. So it will return 0, 0, 0. Same would be the case for numeric. Okay, and I want you to check what happens if I want to create a logical empty vector. Okay, so this was about the vectors. Now let us move on to the factors. Okay, so what are basically factors? What we are going to learn in factors. So here in factors, we would look at identifying the data types in some data frame. Then we would try to identify categorical variables and their conversion to factors. Then we would try to identify levels in the factors and changing levels of the factors. Okay. So for this particular section, I have used some files which are readily available, and I have saved those files in a folder called R on my desktop, and I've named that that folder as data types. Okay, so if you can see it in the window of files and plots, I have set this folder called data types as my working directory, and I would access the files in this data type, which are namely mylist.r, myfactor.r, captaincy.data.csv. These files are readily available. I would be providing them along with the instructions in this video as well, and you can store them in one folder, and then you can set that folder as your working directory. Okay, so I have already set this data types as working directory, and I would access files from this as and when needed. So for factors, I need this file called myfactor.r. This I have opened in the source window, as you can see it over here. Okay, and now let me run this file and let's check what happens. See, it opened the captaincy data frame. Okay, it created the captaincy data frame in it, and I would be using this. Okay, now I want to identify the data types in this particular data frame. For identifying the data types in this data frame, the command is str, and I want to identify the data types of this data frame captaincy. I would write the name of the data frame in str and hit control enter because I wanted to run that command, and you can see in the console the output. It returned me the output of the data frame. See, you can compare this data frame and along with the data types in the console. Okay, so here you can see there are 9 variables, each is having 6 values. Okay, so the very first sentence it shows is 6 observations of 9 variables, and it has returned us the data types for these variables. As you can see, for years it is integer, played is integer, won is integer, lost is integer. For victory it has returned numeric, for drawn again it is integer, for defeats numeric, for formats integer, and for the names it has returned something called as factor. And if you can see is factor, this W/6 means factor with 6 levels. Okay, so factors with 6 levels, and it has returned their values of that. Okay, so in R, basically the factors are used to categorize the data. Okay, factors are used to categorize the data and store it as levels. So what are basically factors? These are the variables in R which take a limited number of different values, and they are often referred to as categorical variables. Okay, so let us see how we can extract uh, the data in the names column. Okay, so for that, let me now write my commands in the console itself. It will help me to see the output then and there itself. To save that, you can write it in the source window and run the command, but I would do it here itself because I just don't want to store it. I want to show it for the understanding purpose. Okay, so print captaincy dollar names. If I give this command, you can see that it will type all the entries in the names column in the console, and also to each name it is calling the level. Okay, why it calls the level, how, that we will see in a few minutes. Now here by default the str command considered named as factors, isn't it? But we know that names probably may not categorize the data, but names are actually of character type. So we can change the data type of the names from factor to character. Okay, so for that we have the command. So how to change the data type in the data frame? So captaincy dollar names. Okay, this back arrow, you know this significance of this back arrow, and here I would be using the command as dot character. See, it is similar to the as dot integer command. So as dot integer was whatever you write inside the bracket, it would return the integer value. So here whatever uh, you want as character, you need to write it in the bracket, isn't it? So captaincy dollar names, I want to be in terms of characters. Okay, so I have created that, and let's check whether it has been executed by giving the str command. Okay, so let me give str of captaincy and check. See, if you observe that this names have been the data type of names have been changed to characters. All right, now question is now how one can identify the categorical variable and how we can change its type to, as I said, the categorical variable has the type factor. The data type is factor for the categorical variable. So first we try to identify the categorical variable from the data frame, and we would change its type to factor if it is already not given to be factor. Now observe the last column called formats. Okay, so in formats you can see three values, 1, 2 and 3. Okay, but these are formats of your cricket matches. So there are three formats of cricket matches. What are they? Test, ODIs and T20s. Okay, so accordingly formats are taking values 1, 2 or 3. So it is showing which captain has played in all the three formats, in only one format, or only in two formats. Okay, so I can see that the format should be the categorical variable over here, because it can categorize this data, okay, as per the forms of the cricket matches. Okay, so we will change the data type of formats. So for that, what should be the command? Command over here is, now I'm looking at the last column. So dollar, and name of the column is factors, formats. So let me type formats, and then I can give the command factor. Okay, factor of, again, the captaincy format, isn't it? Captaincy dollar format, and check what it gives me by giving the command str of captaincy. See, if you can check it over here, the last row, formats, it has been changed. The data type of formats have been changed to factors with three levels, 1, 2, 3, and values of the levels are returned as per the column. So here we can see that there are three different levels, 1, 2 and 3, because only three type of formats are there, isn't it? So here factor function is used to create the factor. These levels are of, and the levels 1, 2, 3, if you can see, they are of character types. So factor levels are always of character types. Okay, if you can see it in the previous commands as well. So here, when it returned the names as factors, you can see that they have written in the double quotes, which is the character type, isn't it? So levels are in terms of characters. Okay, so levels in the factor are always of character type. Now we can also check levels of factor variable using the level function. Okay, so for that I can use the command levels of captaincy dollar formats. So what it gives me the levels 1, 2 and 3. Okay, now can we change the appearance of these levels as 1, 2, 3? See here, I can see in double quotes the levels as 1, 2 and 3. Let me change them to say the instead of 1, 2, 3, let me use the characters as say ABC. Can I do that? So for that, command is levels of the formats in the captaincy data frame. So here what we have is, so let me recreate them, in fact not create, recreate them as say A, B and C, and let me press enter and let me print the levels or the print the last column and check what it gives. See, if you can see here, it has uh, changed the values to ABC. In fact, I need not mention that it takes the corresponding values. It takes A for 1, B for 2, and C for 3. And the levels it has created are ABC. Okay. So this was about the factors in the data frame. Okay. Now let me talk about lists in the data frame. Okay. So this is another important data type in R. And here we would look at how one can create list, how we can access the elements of list, how we can perform indexing on the list, and how we can combine the list. Okay. Basically, what is the difference between the lists and atomic vectors? In atomic vectors, we had quantities of the same data type. In lists, we can have a combination. In lists, we can have combination of different data types. We can have combination of data frames and matrices and vectors and whatever things we wish to have. Okay, so that is the main advantage of lists. And we will see the commands related to the list as well. For that, I would be using the source file called mylist.r. You can see this mylist.r over here, and let me run the file in source. And so again, I got this captaincy data frame. Okay, so now you can see this captaincy data frame. Now let's create a matrix, say, of the first 3 rows and the columns played, won, and lost over here. So suppose I want to create a 3 by 3 matrix with the first 3 entries in the columns played, won, and lost. Okay, you already know actually how to create the matrix, but I'm creating some objects so that I can create my list. So one of the objects which I want to create is the matrix. So the command is subdata. This command you are already aware of. We have seen it in our previous lessons as well. And in that, see, here I would be giving you the indices of the rows 1 to 3, and it should be created with the help of the columns played, won, and lost. All right, so let me hit an enter and let me call this subdata as matrix A. So let me write the name as matrix capital A I would call, and it would set this subdata as my matrix. Okay, so this as dot commands are generally used to create the desired objects, okay, or the objects of the desired type. So let me write this matrix. You can see this matrix as well, but let me create, okay, if you want to see the matrix, so let me put the command print matrix A. So you can see that this submatrix from the data frame has been created. Okay, now I want to create one more vector. Say, let's call this as sample vector. Say sample V. Let me call it as sample V, and suppose it takes the values from 1 to 5. It's a null vector. We can see how how does this vector looks. So this you already know, but I'm just showing it for the sake of clarity. So this vector with elements 1, 2, 3, 4, 5 has been created. Now I want my list to have these three items. The captaincy data frame I want this matrix also, and I want this vector also in that list. Okay. So as I said, list in our object, it has components of mixed data types, isn't it? So the command which I would give is, this is the name of the list, my list, and I want to be list of. So list is the function, or list is the command, and it should have what? The name of the data frame is captaincy. Okay, then name of the matrix is matrix A, and name of the vector is sample V. All right, so this would create the list. If I want to display the names of the, suppose if I want to give particular names to the elements in the list, let me give the names also to identify these different elements. So let me give the command my names of my list, means names of the elements in my list. Okay, so I would create them to be, say now, captaincy is the data frame. So names are in characters. है ना? Matrix A is a matrix and sample V is a vector. So I'm giving them the names as per their nature only. And now let me print this list. So print my list. See, let me adjust this console window. So if you can see here, it gives me the list of, see, data frame it has displayed. Then second element was matrix, which it had displayed, and the third was the vector. Okay, so in this way one can create the list. And I have given them the respective names as data frames, matrix, and vector. So it has displayed their names as well. Now, how to access elements in the list? Okay, so elements in the list can be accessed by their name or by their index as well. So this is called as indexing. So here my list was the named list. I had given names to the different elements, so I can access them with the name as well. So let me first access them with the name. So my list dollar, suppose I want to access this matrix. So if I give the command mylist dollar matrix, it would show me the element named matrix in my list. Okay, but I can, if suppose I don't give names to the elements, so is there any way to access those? Yes, we can access them by their number in that list. Okay, so let me write my list, and suppose now I want to access the third element, which is vector. So I would just put the index in the square brackets, and you can see that it will return me the output as vector. Okay, that was the third element. So in this way, we can access the elements in the list By two ways, either by naming them or by their index. Okay, now in particular, if I want to access a particular element in the matrix in the list, okay, so how one can do that? So matrix was the second element in my list, and from the matrix I want to access some element. Suppose I want to access the third column. So for third column, I first put row and then column. I don't want to access the row but the column. So I would put comma and the 3. So here 2 is the second element of the my list, and this comma 3 is the third column of this second element. Okay. So if I put enter, you can see that third column in the matrix is 14, 6, 12. See, the third column is 14, 6, 12. Isn't it? So in this way, we can access a particular element. So similarly, we would be able to access the row as well. Suppose I want to access the third row, then I would put the column to be blank. And let's check. See, this is the third row, 45, 22, and 12. And it also gives you the names of these columns. So played, won, and lost. If I want to access, say, the middle entry, which is 2, 2 from the matrix, it returned me 8. See, this is the entry in the second row, second column of the second element of my list. So in this way, we can access particular elements in the list as well. Okay, so now we know how to create list, how to name the list, how to index the list, or how to access elements in the list. And now let's check how we can merge two lists. So here I had one list called my list. Suppose I want to append one more list to it, and suppose that list is a simple list having a single vector. So let me create one more list called as, say, let me create a sample list, say list sample. Let me call it as sample list, and the more appropriate name. Let me create a sample list, and in fact I'm creating a single vector and calling it as a list, because even if it has only one type of elements, still it is a list, isn't it? Though you can say that it is only an atomic vector, but anyways, I'm just showing it for the sake of understanding. So sample list I created, and now I want to merge the sample list with my list. So the command for merging is merged dot list, which is created by merging my list with the sample list. Okay, so let me hit an enter and let me give the command print the merged list, merged dot list. So the command is merged dot list to merge two different lists. So if I hit an enter over here, see, you can see now the two lists have been merged. The first list had elements data frame, matrix, and vector, and the last had two characters, 1 and 2. So these are two separate, what we can say, the two separate elements in that list. Okay, and in this way, we are concluding this lesson here. Just to have an overview, we talked about different data types, we talked about factors, we talked about the lists. All right, now you should explore some more features by creating your own examples in this, and then it would be a fruitful session. Okay, so here I would stop my session. Obviously, uh, do try out these problems, or do try out the commands which are mentioned in this lesson. Okay, this is Sandhya Tapadia signing off. Happy learning hour. All right. So